Assalamualaikum warahmatullahi taala wabarakatuh. We are from JCDCS 144A. Our course code is MAT263. So today we are going go to present our case study. Our title is Football Match Ticket Price. This case study is prepared by four of us. First is Muhammad Arif bin Ami Hussein. Second, Syed Iskandar bin Muhammad Asri. Third, Amirul Amin bin Abdul Jamal. And lastly, me, Muhammad Farinsha bin Nur Hashim.
Hi everyone, today we are going to present our case study. You guys have probably noticed this before, but when we buy football or movie tickets, the price usually vary based on age groups like adult, teenagers and children. This pricing strategy is great because it keeps tickets affordable for fans while ensuring club or cinemas still maintain a steady revenue. However, the tricky part is that when we buy these tickets together, the receipt usually only show the total price paid, not the specific breakdown for each ticket category. So, how do we find out the exact individual prices? That's where maths come in. In this case study, we will show how we can use Cramer'S rule to easily calculate the price of each ticket type just by using the total cost from different ticket combination. Let's check out how it works.
Purpose of study. First, to apply linear algebra concept to solve the problem that we are facing on in our daily life. Next, to test the efficiency and reliability of Cramer rule in solving problem. And lastly, to determine the price of football ticket match for each category age group.
So, our question or problem in this case study is, on the first football match, Ali buy football ticket physically. He buy 4 adult ticket, 2 teenager ticket and 3 kids ticket with total RM 111. On the second match, he buy 2 adult ticket and 6 kids ticket with total RM 66 on online platform A. On the third match, he buy 3 adult tickets and 5 teenager tickets with total of RM 114 on online platform B. Find the price ticket for the category adult, teenager and kids.
So we are going to let X as adult, Y as teenager, and Z as kid. The equation we can get from the equation just like you see in the slide. So I'm just going to find the determinant of A. So we are going to do the cofactor expansion along the second row since there is a 0 in the second column. So you may notice there is color of line. So that is just the way of me to help you visualize. You look at the yellow line where is intersect. What number is it? So it's 2. Why negative? You can look at the way to read the symbol matrix that I do. So that's why it's negative. That's why it's 0. Look at the pink line where 2 times 0 is 0. Then we need to minus the blue line, which is 5 times 3, where you get 15. So next, plus 0. Since 0 times anything number, you will get 0. No need to do anything further. And then for the negative 6, bracket of 20 minus 6, same way like the first thing we do, where you can see the intersect for the yellow line is 6. And then negative, the ways to reach the symbol of matrix. And then we bracket the pink line, which is 4 times 5 minus the blue line, which is 3 times 2, you get 6. The answer for the The determinant of A is negative 54. So continue to solve the question. We need to find the determinant of A1, A2 and A3. So the ways to do it, we just need to change the column number 1 for the determinant of A1 with the column constant, while the remaining column stay the same. Same for the A2, change the column number 2 with the column constant. So the column constant you can see in the equation is on the right hand side. So for the determinant of A1, I do the cofactor expansion along the second row. For the A2, I do the cofactor expansion along the third row since there is a 0, while for the determinant of A3, I do it at cofactor expansion along the second row. For the last part of calculation, we need to find the value for each variable. For x, we will use the determinant of A1 divide with determinant of A. Why we use the determinant of A1? So the ways to find the determinant of A1, we will replace the column 1, which is x located at, with the column constant. So to find the y and z is the same, where determinant of A2 divide with A, while z determinant of A3 divide with the determinant of A.
So, let's moving on the most exciting part, which is our result. After applying Cramer's rule to our system of equation, we successfully found the exact price for each ticket category. As you can see on the slide, the calculated price are RM18 for an adult ticket, RM12 for a teenager ticket, and RM5 for a kid ticket. What's really interesting is that our calculation gave us a unique solution. This means that these prices are completely fixed for each category. So it doesn't matter if you buy a physical ticket at the counter or purchase it online through platform A or platform B. The base price remains exactly the same. This proves that our mathematical model works perfectly to break down those hidden individual costs. Next, let's wrap things up with our conclusion.
The conclusion for our case study is, in conclusion, this study proved the efficiency of linear algebra concept to solve daily life problem. Price of a football ticket match for each category age group successfully determined by using Cramer's rule.